So in the previous activity, you should have learned about transformations of our three types of functions that we need to know in Math 2: quadratic, square root, and inverse variation. It's important that you know that quadratic functions have an x squared and they make a U-shaped parabola. Square root functions look like this shape. They stop at one end but keep going forever at the other end. And inverse variation functions, which have an x on the bottom or a variable on the bottom, are going to make this general shape, and they have what's called asymptotes. And we change these parent functions around by moving them using h and k and also a as well. Now we're going to add on to that with some intervals. We already have some experience with finding the domain and range. Let's review how we find the domain and range for these. The domain is going to be how far from left to right a graph goes on the axis. That's how you can visualize it. It's always going to be all of the x values that can be plugged in to a function. And if you look back on the first page of this packet, you could probably see a reminder for how we find the domain and range for these. So the domain is, for this graph, how far from the left to the right that it goes. So what is the farthest to the left on the x-axis and to the right? This graph goes from -6 on the x-axis. -6 is the farthest it goes to the left, and it keeps going forever to the right. We always put parentheses for infinity. And since -6 is included here, we're going to put this bracket here. The range talks about how low to how high it goes. So on the y-axis, what is the lowest and the highest that it goes? 1 is the lowest on the y-axis, and it keeps going up forever. So the range is going to be 1 is the lowest, it keeps going up forever, infinity is the highest. Something new we're going to talk about is increasing and decreasing. Intervals where the function is increasing talk about literally when the graph is going upwards as you move from left to right, and decreasing is talking about how when the graph is going downwards as you move from left to right. And the thing with these intervals is you're always going to tell the x values. So for example, on this sheet you can see, let's see if it'll let me zoom in here. This graph here is increasing from here to here. And we tell them where it is increasing using the x-axis, not the y-axis, but the x-axis. So this graph is increasing when x is between 2 and infinity. This graph is decreasing from -infinity to 2. That's an example. As we look at this graph, as I move from left and right, we start at -6 on the x-axis, and it is going to be increasing always. So for all x values of the domain, it is increasing the whole time. As your x's increase, as you move from left to right, it is always increasing. It is never decreasing, so we're going to put 0 with the line through it. That means empty set. And let's look at when this function is negative. Okay, looking at when it's negative and positive is looking at literally when it is above and below the x-axis, using the x values again. So the graph is above the x-axis, that's going to be when the function is positive, and then below the x-axis is going to be when the function is negative. This entire function is above the x-axis, so all of our y values for this function are positive. So the x values, again, when you tell these intervals, you're always going to use the x values. It is never negative. So we're going to put that 0 with a line through it. Okay, this is difficult. Hopefully with some practice you'll understand. I know it's very confusing. One of probably the hardest things we do in this class, in my opinion. Now we're going to talk about end behavior, which talks about what happens, basically where the arrows are pointing. Whenever you write the end behavior, you're just going to copy this right here. Let's look at this next example. In my opinion, parabolas and quadratics are easier to see these intervals. The domain and range we've had some practice with already. The domain is how far the graph goes from left to right, and we know that quadratic functions, parabolas, always go forever to the left and forever to the right. So it's always going to be negative to positive infinity, because they always go forever to the left and right, because you can plug anything into a quadratic function without any issues. The range we look at from bottom to top, the lowest to the highest this graph goes. Does this graph keep going down forever? Yes, it does. Negative infinity is the lowest it goes. And on the y-axis, what is the highest it goes on the y-axis? 4 is the highest that it goes. So no matter what you plug into this function, you're never going to get out a number that's any higher than 4. Let's look at when this function is increasing. As x increases, that just means as we move from left to right, where is the graph increasing? So as x increases, this is increasing on this part of the graph here. It's increasing at first. So let's look at the x values when it is increasing. If we start from left to right, as we go to negative infinity, this graph, as I move this way, is going to be increasing until we get to where? On the x-axis, and this one, I notice this is 1, 2, 3, 4, the graph stops increasing when x is 1. Right here is where it stops increasing. So it is increasing on the, we tell where it's increasing. It's increasing here on the x-axis. That means it's increasing from negative infinity to positive 1. We know we always use parentheses anytime we have infinity. And when we're talking about increasing and decreasing, we're going to use parentheses for the number as well. That means 1 is not included. Why is 1 not included? Because if we look at the graph right here, is the graph increasing at 1 or is it decreasing? Neither. It's not increasing or decreasing. It's switching there. So now the graph is going to start decreasing. It's going to start decreasing, and we let them know where it's decreasing by looking on the y-axis. It starts decreasing when x is 1, and it continues decreasing until x is infinity. Okay, so from when x goes from negative infinity to 1, the y values are increasing. After 1, the y values are decreasing. Let's look at the intervals where the graph is positive. And remember, for these intervals, we say on the x-axis. It is positive, that just means where it's above the x-axis. Negative means it's below the x-axis. This graph is above the x-axis for all of these points right here. Let's tell them where that is on the x-axis. When does it become above the x-axis? Negative 1 is when it starts becoming positive. and then it is positive until we get over here, which is 3. Notice I put parentheses for these as well because, again, it is not above the x-axis at these points. It's not above or below the x-axis. So that's why we put that it's parentheses, because those numbers are not included. Now let's look at when it is below the x-axis, and these have arrows. So we're going to have a union, a set of numbers. So as we start over until we get, so basically when x goes from -infinity to -1, all of these y values are going to be negative. And then it's going to be negative again for what values of x? Starting at 3 and going to infinity. So it's negative from -infinity to 1. We put a u for union when there's more, sorry, this is -1. A u for union when there are more than 1 intervals. You might need to watch this video again because, again, I know this is confusing, but this is basically saying that our graph is above the x-axis when x is between -1 and 3, and all the other times it's below the x-axis. The output is negative. Now let's look at the end behavior. Anytime you're asked to tell the end behavior, you just look at, you copy this down right here. As x, this line means approaches -infinity. All that is saying is when you move to the left. What happens to the function when you move to the left? As we move to the left, this function is approaching where? It is approaching -infinity. It is going down forever. Okay, and then this one says as x, this means approaches positive infinity. That's just a way of saying as you move to the right, what is the graph getting closer to? And looking at this graph as we move to the right, what y values are we getting closer to? Also -infinity. So this approaches -infinity on both sides. All this end behavior is saying what happens at the ends of the functions, where the arrows are getting closer and closer to on the left side of the graph and on the right side of the graph. Let's do one of these lovely inverse variation functions. The domain, how far the graph goes from left to right, and we have asymptotes for this one, so we've got to be careful. This doesn't go forever to the left and to the right with no interruptions. There is an interruption at -2 on the x-axis. So we say that this graph continues towards -infinity on the x-axis. We always use parentheses with infinity. And then it keeps going until we get to -2. You cannot plug -2 into this function. So would I put a parentheses or a bracket here? We're going to put parentheses because -2 is not part of the domain. And then from -2 to infinity. So this is basically saying any number can be plugged into this function except for -2. Now, why do you think -2 cannot be plugged into this inverse variation function? Well, obviously, it must be a number that you would plug in that would make the denominator equal 0, which means you would be dividing by 0. The range is how far this graph goes from bottom to top. This graph does keep going down forever. Okay, and all of these, we're using all of these y values except for this 1 right here. We're not using the 1 on the y-axis. So that means no matter what you plug into this function, you're never going to get a 1 out of this function. Okay, and then we're going to say that on the y-axis it goes from 1 to infinity. 1 is not included, 1 is not part of the range, that's why we put parentheses. Let's look at when it is increasing as we move from left to right. If I am moving from left to right here, is this increasing or decreasing? It is decreasing. Okay, what about up here? As I move from left to right, is this increasing or decreasing? It is always decreasing. Okay, it's never going to be increasing, it's always going to be decreasing, except obviously when I get to -2, you can't, it's not increasing or decreasing, it's undefined there. So we're just going to copy the domain for decreasing because for all x values, it is decreasing for all x values other than -2, which can't be plugged in anyway. Positive intervals, we're looking at where it is above the x-axis. So let's take a look at where this graph is above the x-axis. I see it's above the x-axis here, and it's above the x-axis here. By the way, these dotted lines are not counted as part of the function. They're just asymptotes that are drawn, but they should be invisible. So let's look at the intervals and look at where this is on the x-axis. I see right here, and if I smush this down to look at where this is on the x-axis, okay, the places where it is positive are going to be, if I keep drawing this here, will be from -infinity. Okay, and then it becomes negative from negative infinity, and then on the x-axis it becomes negative when we get where? At -5. At -5, it's going to switch from positive to negative. At -5, it is neither negative nor positive, so we're going to put parentheses. It's not included because it's not negative or positive. Okay, and then it becomes positive again right here, which is -2. Again, not included because you can't plug in -2. And are all of the rest of these x values going to give you a positive y value? Yes. So from -2 to infinity, this function is positive above the x-axis. Now let's look on the x-axis for where it is negative. It's going to become negative right here at -5. And on the x-axis, it still is negative until we get to -2. Now you might notice with these intervals that they are going to continue, I don't know what the right word is, but basically this is going to pick up where this left off, and then this is going to pick up where this left off. I don't know if that makes sense to you. I can't think of a better way to say that. Maybe I'll think of a better way to say that. But lastly, let's look at the end behavior. And we're looking at, as you move to the left and go on and on and on and on, what does the graph get closer to? Let's see. If we keep on going forever to the left, okay, this is not going to go to infinity. It's not going to keep going up. It is going up forever, but not towards infinity. What is this approaching on the y-axis? It is approaching +1. So as x goes to -infinity, y is getting closer and closer and closer and closer to 1. On the right side, are the y values also getting closer and closer and closer to 1? Yes, they are. So when we have rational functions that we're finding the end behavior for, it is going to be the horizontal asymptote that it approaches over time. Again, I know some of this is confusing. I'm sorry I didn't put it in the curriculum. Just trying to make it as simple as I can for you. All right, state the end behavior. Now this time we don't have a picture of the graph. So let's give this a try and let's think about, we need to use everything we've learned in the past couple of lessons to find the end behavior. We need to think about what this graph looks like. Since this has an x on the bottom of the fraction, I know that it's an inverse variation function, so it's going to make this general shape. And this is 1 over x minus 4. You can tell that that looks like this a over x minus h. And what would this minus h, or minus 4, do to the graph? That would shift it to the right 4 units. So if we were to draw kind of a rough sketch of what this looks like, our parent function has the asymptotes at 0 and 0, but this is going to have a vertical asymptote at x equals 4. So if I come over here, I'm just drawing a rough sketch of what this would look like. And the horizontal asymptote is at y equals k. Well, this doesn't have a k written, so what could be written out here? What could I add to this that wouldn't make a difference? Plus 0. So this has a horizontal asymptote at 0. So our rough sketch of this graph is going to look like this and like this. Okay, so it's just like this graph, except it would be shifted to the right 4. Anytime it says state the end behavior, we're just going to copy down what this tells us to do for the end behavior. We'll just copy this down right here. The first part of the end behavior is going to be as x approaches, that's what that arrow means, negative infinity. That's another way of saying as you move to the left. As x approaches negative infinity, y approaches something. And as x approaches positive infinity, what happens to the function over time as well? As x approaches negative infinity, as I move to the left forever and ever and ever, the graph is going to get closer and closer and closer to what? It's going to get closer and closer and closer to 0. Same thing on the right side. As I move forever to the right, the graph is going to get closer and closer and closer to 0 as well. So like I said a few minutes ago, for the variation functions, the end behavior is always going to approach the horizontal asymptote, because y is going to get closer and closer and closer. The next one says to state the values, the x values, for which this is negative. And what we're going to do is think about what this graph looks like. First of all, is this graph going to be quadratic, square root, or inverse variation? It is quadratic because it has a 2 exponent, so it would make a parabola. And let's think about what the 3 and the 9 would do to this parent function. The parent function would be a parabola that has a vertex at 0, 0. And what would the 3 do to this parabola? The 3 would do a vertical stretch, so that would make it steeper and narrower. Okay, so it would be a little bit more like this. And what would the plus 9 that's like plus k, what would that do to our parabola? That k, since it's outside of the function, would move the graph up 9 units. So it'd be something a little bit like this. All right, it says, when is this going to be negative? Well, remember, when the function is negative, the intervals where it's negative are going to be below the x-axis. So when it's below the x-axis, that's going to be the negative intervals. When is this graph below the x-axis? It's not. It never goes below the x-axis. So there are no x values when this function is negative. There's nothing you could plug in that would give you a negative. If it asked when is it positive, we would say the x values from negative to positive infinity give us a positive. Okay, the next one wants us to find the domain of this square root function without a picture of the graph. So again, we'll think about what transformations are taking place to the parent function when there's a -4 and a -7. And then we'll think about what the domain would be. So if I have my square root parent function here, what would this negative do? The negative is going to flip it over the x-axis, okay? The 4, if you're multiplying a 4 on the outside, that's going to do a vertical stretch. So that would be like taking it and stretching it this way. And what would the subtract 7 underneath the square root do? That's going to move it to the right 7 units. So this would be now at 7. Our start point would be at 7, 0 over 7 of 0. The domain is how far the graph goes from left to right. So we're going to look at where we start on the x-axis and how far from left to right it goes. So on the x-axis, I am starting at 7. And is it going to keep going forever to the right? Yes, it will. So 7 to infinity. We know for infinity, we always use parentheses, and would the 7 be a parentheses or a bracket? The 7 is going to be a bracket because 7 is included. You can plug a 7 into this function, but you can't plug in anything smaller than 7. What would happen if you plugged in a number smaller than 7, like 3? If you plugged in a 3, that would give you a -4. Uh-oh, we have a negative under the square root. That's a problem. So that's why 7 to infinity would be the domain. Notice I'm able to find these without a picture of the graph. And what is the range of this function, which is which type of function is this? If it's 3 over x plus 4 minus 5, it has a x on the bottom. Okay, so that means it's an inverse variation function. And if we think about what the graph looks like, it's going to look like this. It's going to have a vertical asymptote. If we look at this, the vertical asymptote is going to be at h. So is the vertical asymptote going to be x equals 4? No, it's not, because remember that h, the one on the inside of the function, is tricky. So x equals -4. That's going to be my vertical asymptote. And the horizontal asymptote would be where? Y equals k. So y equals -5 would be my horizontal asymptote. Okay, and there's no negative in the front, so it's going to be in this corner and this corner. The 3 is going to stretch it vertically, but that doesn't affect the range. The range is how far from bottom to top the graph goes. Okay, this graph is going to keep going down forever, so negative infinity. And does it keep going all the way up forever without interruptions? No, it stops going up at the horizontal asymptote. That's a y value that cannot come out of this function. So we would say that it goes from negative infinity, we're good, until we get to -5. -5 would never come out of this function. And also, then we would go from -5 to infinity. That is the range. You might remember on the first page of this packet, we put our generalizations. This one was inverse variation, so that was on the second page, that the range is going to be everything except the horizontal asymptote. So you can use that. Okay, this next part here is going to be challenging. I want you to just try, see what you could do without a calculator. Use all of this to help you.